Hi, in this video, we'll be seeing about the CPU scheduling algorithms. So before getting into detail about the CPU scheduling algorithm, we will see what is CPU scheduling. So CPU scheduling is a process of determining which process will own the CPU for execution. As we know, the process that are ready, it will be available in the ready queue. From the ready queue, it has to be taken and it has to be handed over to the CPU when the CPU is free. So we need to determine which process we need to take it from the ready queue and it should be given to the CPU. So for this case, we will be having a CPU scheduler. The CPU scheduler will pick the process from the ready queue and it will give it to the CPU for its execution. So in order to decide which process to pick, we need to use these CPU scheduling algorithms. So using the CPU scheduling algorithms, the CPU scheduler will know which process it has to take it from the ready queue and it has to give it to the CPU. So we will be seeing the CPU scheduling algorithms. Before we get into detail about the CPU scheduling algorithms, we need to know about some of the terminologies of CPU scheduling algorithms. So the first terminology here is the burst time. So it is the amount of time required by the process for executing on a CPU. That we call it as a burst time. So the second time which we have is the arrival time. So it is the time at which the process arrives in a ready queue. That we call it as arrival time. And the next time we call it as completion time. So it is the time at which the process completes its execution. And the next one is called as turnaround time. We call it as TAT. So it is the time interval from the time of submission of a process to the time of completion of the process. So here as you see, the turnaround time, we can't find it out directly. So we need to know the completion time and the arrival time. If you know the completion time and the arrival time, we can able to find out the turnaround time. So this is completion time minus the arrival time. So the next time which we have is the waiting time. So this is the time spent by a process waiting in the ready queue for getting the CPU. So here also, once again, waiting time, we can't directly find it out. So in order to find out the waiting time, you need to know the turnaround time and burst time. If you know the turnaround time and burst time, you can able to find out the waiting time. So these two are the important, actually the formulas to find out the turnaround time and the waiting time. So we will see one example so that you will know how the ready queue, for how the process from the ready queue is taken and it is handed over to the CPU. So we'll see the first algorithm. So the first algorithm here is the first come first serve scheduling algorithm. So this is the non-preemptive algorithm. Non-preemptive in the sense, if one process is running in the CPU, until that process finishes, that process will hold that CPU. So whenever a higher priority process comes in also, it is not going to suspend the process that is currently running and take in the higher priority process. What it will do is it will leave that particular process that is currently running to finish its execution. So once it finishes its execution, then only the next process can go in and it can execute. Okay, so that's why we call this as non-preemptive algorithm. So here this first come first serve algorithm, it purely depends on the arrival time of the process. So we will see an example here. So here they have given an example. So I have PIDs, that means the process IDs. So I have three process P1, P2, P3, and I have the arrival times for those things like 000. That means all the process, my P1, P2, P3, all the process, it arrived at the same time. Okay, it arrived at the same time and it is there available in the ready queue and it is waiting for the CPU. So the next one they have given is the burst time for the process. P1 is 25, P2 is 5 and P3 is 5. Burst time is nothing but the amount of time it takes to run in a CPU. So that we call it as the burst time. So once this is given to you, so here you see the condition, it is with zero arrival time. Okay, all the process arrives at zero. Okay, so it is not having any different arrival time, it is having zero arrival time. That means every process is there in the CPU at the same time. Okay, once it is given, you have to check the arrival time, and then you have to draw the Gantt chart for it. Gantt, Gantt chart. Okay, so how to draw the Gantt chart? We have three process. So as we know, first come first serve. That means which process comes in first, that has to be given the CPU first. So we know P1 comes first, and after that P2, and after that P3. So in this order only it has to execute. So I'm going to draw the chart for this. So I will take like this, and the first process to come in is your P1. So it executes till 25 milliseconds. Okay, so 25. It starts at 0, it gets completed at 25th millisecond, and after that the CPU will be given to your process P2. Now the process P2 will come. It takes 5 milliseconds to complete. So how much it will take? So 25 plus 5. On 30th millisecond, your process P2 will be completed. And the next process to come in is P3. It also takes 5 milliseconds. So P3, it takes 5 milliseconds. So 30 plus 5, it gets completed at 35th millisecond. So once this is done, once the Gantt chart is done, the next thing which you have to do is the find out the completion time. CT, we call it as CT. So this completion time, you can take it from the Gantt chart itself. Okay, so here you see when is your process P1 got completed. It got completed at 25th millisecond. Just note that 25. And when your P2 got over, it got over at 30th millisecond, right? So 30. And when your P3 got over on 35th millisecond, so 35. So these are your completion time. So the next one which we need to find out is the turnaround time. So turnaround time, you know the formula, TAT is equal to CT minus AT, right? CT minus AT, that's what we saw before, right? So in this, I told you, it is the completion time minus the arrival time, right? So that's what we are going to use here. So here, as we see, all the process arrives at the same time, like 0. So your completion time is 25, 30, 35. Your turnaround time will also be the same because your arrival time is 0 over here. Okay. So when I find out CT minus 80, CT is 25 minus 0. Once again, your turnaround time for your process P1 is 25. For your process P2, it is 30 minus 0, it is 30 once again. 35 minus 0, it is 35. Okay, so turnaround time is over. The next time is the waiting time. So waiting time formula, you know, waiting time is nothing but turnaround time minus the burst time. Okay, you know turnaround time now, you know the burst time now. So do it. 25 minus 25, it is 0. 30 minus 5, it is 25. 35 minus 5, it is 30. Okay, so why this is 0? Because when the process P1 enters, that time your CPU is already idle and it is free. So at the 0th millisecond itself, it got the CPU. That's why it is 0 over here. So once this is over, once this particular table is over, we need to find out the average turnaround time, average TAT. So how you will find out the average TAT? You know the TAT values of all the three processes, right? So you have to add it, like 25 plus 30 plus 35 divided by the total number of processes. Here the total number of processes is 3. So divided by 3. So that means it is 30 milliseconds. Okay, so average turnaround time for a single process is 30 milliseconds. And the next one is average waiting time. So average waiting time, you know the waiting times of all the process, just add it and divide by 3. 0 plus 25 plus 30 divide by 3. So it will be 18.3 milliseconds. So this is the average waiting time for a particular process. Okay, particular process, it takes 18.3 milliseconds waiting time. Okay, it is an average waiting time for each and every process. So this is how you need to do for the FCFS scheduling algorithm. This is how your FCFS scheduling algorithm works when your arrival time is 0. In the next video, we will be seeing about when we have a different arrival time, how it works, how your FCFS algorithm works. We will see it in the next video. Thank you.